Okay, good evening, guys. We are still in tutorial 1, language and grammar. So, in the tutorial batches, I have actually completed 1A, B, D, E, and E, F, G as well. Okay. So, certain tutorial batches. Certain tutorial batches. We have done only 1A, B up to D. Okay, so don't worry. As I told you yesterday and day first day, not day first day, I told you yesterday, the Wednesday batch tutorial who attended yesterday, you missed the previous week Wednesday class because it was a May 1st Labor Day public holiday. Okay, so that batch will be slightly behind, but don't worry, we will cover it up. Okay, so, so today what we are going to do is I'm going to continue with what we did in the last lecture class. The last lecture class I was actually discussing about question 2. Question 2 was to construct question 2 was to construct a regular grammar. Okay, so we discussed what is regular grammar, what is context-free grammar, and I discussed the solution for question number 2C. So that's what you're seeing on the screen here. So we discussed the answer for question 2C. But if you see, I arrived at this answer. And certain, not certain tutorial batch, the tutorial batches I taught, I did the tutorial, I explained in the class that the answer that I've arrived in the last week lecture on 2C is this one, is not a regular grammar, is a context-free grammar. Okay, I have given my comments also here. The grammar that we have constructed is context-free grammar, as the right-hand side of the S rule has more than 2 letters. So we need to improvise the above grammar to get a regular grammar where the right side of a rule does not have more than 2 letters. I have mentioned that. I'll explain in next class how this can be done. So I'm going to explain that. Okay. So if you see, actually this is the answer we have arrived at for 2C. Okay. So how we have done this means, so his answer is here. So I have taken this whole part as capital A. See, I have given here when A is equal to A or B or C, kanista. So when I take this whole part as A, I can simply write this as AA followed by BA. Okay. So where I need to see how to expand the capital A. So I have written here how to expand the capital A. Capital A can take a value AA or BA or CA or lambda. So with that we can produce any combination of A or B. Okay. But since this S rule has more than 2 letters on the right hand side, it is a regular grammar and not, sorry, it is a context-free grammar and not a regular grammar. Okay. So if you observe carefully, this part of the grammar does not has more than 2 letters on the right hand side. So the A rule follows the definition of a regular grammar. Only the S rule does not follows the definition of a regular grammar. Okay. So I just need to rephrase or improvise the S rule. If I can improvise the S rule, okay, to fit into a regular grammar, I am done. Okay. So what I am doing is, I am going to split this. I am going to split this S rule like this. I am going to take capital A as AA, then capital B as BA. That's what that's what I'm going to do. So I have written it here. So what I'm going to do is, I'm going to show you. I'm going to split this S rule. Okay. So I'm going to split this S rule. I'm going to take this as A and I'm going to take this as B. so that I can expand them. Okay, so I'm going to take this as SAB. So this is going to represent A, and this part is going to represent the B. Okay, so now I need to expand what is A, or how I can replace A as well as B. You have to observe me carefully, otherwise it's going to be a nightmare. And don't complain, I don't understand what the hell is it. So A, I'm going to write it as AA, and B, I'm going to write it as BA. So if you see, the AA is here and my BA is here. Okay, since I have already used A, I cannot use A here. So what I am going to do is, I'm just going to copy this, put it here, and I am going to modify this. Since I have already used capital A, I have to use some other letter. So I simply use capital C. So I take this as AC, BC, CC. So now, if you observe this context-free grammar, I have improvised it to become a regular grammar. So in this grammar, if you see at the bottom part, the grammar I've written, the right-hand side does not have more than 2 rules. Correct, right? So you may ask why you do this. Okay? To me, when I look at the question, okay, when I looked at this question, okay, I did not fix my mind, or better, constrain my mind or thought, hey, I have to have a regular grammar. Regular grammar means I should not have more than 2 letters on the right-hand side. So if I'm going to put that constraint, my thought process is constrained. Okay? So what I do is, I don't worry about the number of letters. I just write the grammar. Okay? And it was easy to see this as capital A. So that's why I wrote AABA as my S rule. And then I expanded how to replace the A. Okay? So it was easy for me to think. Just like that, I wrote the answer. Okay? But after arriving at the answer, I realized, hey, I'm not answering the question. The question is asking me to produce a regular grammar. But what I have arrived at is a context-free grammar. So I see where the issue is. The issue is here. The issue is with the S rule. The issue is not with the A rule. A rule satisfies the regular grammar, but S rule does not satisfy. So I think how I can do that. So my thought tells me, why don't I split this AABA as AB, capital AB, and that's what I have done here. I have done here and I have arrived at the regular grammar. Okay? So easy way to see and construct the regular grammar. Okay? So I delete this because it's already there up. Okay? Done. Okay, done. So now we are going to solve 2b. Okay? 2b, do you see similarity with 2c? 2c is here. If you see, 2c, question number 2c and 2b are similar. Only thing is, it's a bit lengthy. Okay? So what I can do is, I can apply the same thought that I applied here. I took A or B or C Kleine star as capital A. Okay, I can apply the same thought. So if I apply the same thought, this is my thought, huh? So I'm going to write the rule now. So what I can do, I can simply say SS, I can take this whole thing as A, capital A, okay? Capital A. What will happen? This A is a mandatory, okay? So I need to have this small a. So I'm going to have A, and I'm going to take this whole thing as capital A again, because I have already assumed here, let A is equal to A or B or C, Kleene star. So this B is mandatory, it must be there. Then again, this whole thing is going to be A. And then you have a union operator, okay? So what this means is, this language is going to produce this pattern of string, or this pattern of string. Okay, something like coffee or tea, or apple or oranges, or banana or guava. Okay, so this or this. So this language is going to produce this pattern of string or this pattern of string. So I put the or symbol here, the union operator, and then again I'm going to follow the same rule. I'm going to take this as A, capital A, okay? Capital A, and after the capital A I have a B here, that B should follow. After the B again I am going to have capital A, and then there is a small a here, so that A should follow, and after the small a there is again a capital A, okay? So if you look at the S rule, definitely it is not a regular grammar, okay? But when I did this, I wrote the S rule, I did not restrict my thought. I did not constrain my thought, hey, I need to write a regular grammar, so on the right hand side I should have only 2 letters. I did not do that. I just wrote the grammar, okay? Because easy to do that. But when it is easy, at the same time I also realize that this is not a regular grammar, okay? But my thinking is, let me solve it first, okay? Let me solve it first. Then I improvise it to become a regular grammar, like we did for 2C. So what will happen in the next step? In the next step, we just need to write what is the value of A. That is, what values A can take. That is the A rule. What values A can take. We have already done that here. Correct, right? So we here also, we took A or B or C, A or B or C to be Kleene star, you see. So, and we know, when A is equal to A or B or C Kleene star, the rule is here. We have already written the rule earlier. Right? The rule is here. So I simply copy paste this here. You see, less than 2 minutes we have solved this. The only issue is, only concern is, this is not a regular grammar, but it is a context-free grammar. Okay? So I'm going to give you some homework, okay? So you need to split this, similar to what we did here. Okay? Apply similar thought. Okay? Apply similar thought. Okay? Apply similar thought such that you break this rule into a rule such that it does not has more than 2 letters. Similarly, you have to break this rule that doesn't has more than 2 letters. Okay, you can see some similarity here. You have A, capital A, then A, capital A, small a, then capital A, small b. You also have that here. Capital A, small b, capital A, small a. If you take this as capital A, and this as capital B, ABA, you can do the same thing here, you know. So just think, because if I am going to solve every problem, you come here and just listen to me, it's not going to help you. You're not going to learn, okay. So I want you to try. Okay? And definitely I know some of you can try, because I am not teaching this the very first semester. I have seen answers coming from students. Okay? But I know out of 180, not all 180 will come with the answer. Okay? Only those who sincerely try may come with the answer. Some may attempt and then they give up. Okay? They say, oh, it's a Herculean problem. Only gods can solve it. I cannot solve it. You know? Can you give me the answer? Yes, I can give you the answer. Okay? Don't forget, if I can give you the answer, every tutorial I can finish in one tutorial class. Okay? There are only about 9 tutorials. I can finish it off in 9 weeks. And I say, syllabus is over. Okay? Your marks also will be over. Okay? So my intention is like the Chinese proverb, right? It says, instead of giving me fish, you teach me how to catch fish. That is a sustainable solution. That's what I'm trying to practice here. I'm teaching you how to solve it. So you can solve any similar problem, instead of merely giving you answers for the questions. If I merely give you answers for the questions, life is easy for me in a way, but in a way it's going to be difficult for me as well, because you're not going to learn. Okay? So I want you to go and try and break this similar to the fashion or style that we did here. Okay? As I said, I'm here to help you, not to punish you. I'm just giving some space for you to learn. Go and try. Okay? Try your hands, getting the problem and getting a grip of the problem and solving it. Okay? So if you come back and tell me, oh, as I said earlier, it's a Herculean task, I cannot solve it, I will show you how to solve it. Not an issue. Okay? All right. So now I'm going to give you directions for 2A. And 2A is an assignment 1 task. It's part of your self and peer evaluation. You are expected to, go home, and whenever you have free time, you sit with your assignment group mates, discuss with each other, and solve 2A. Again, some of you may ask, where should I submit? Should I submit the answer to you? You submit to yourself, don't submit to me. Okay? So what I mean is, these questions are for you to, to force yourself to sit together with your group mates and learn from each other. Okay? That's the best way of learning, collaborative learning we call it as. Okay? And that's where the self and peer evaluation is. To what extent each of you contributed in discussing these take-home exercise, assignment 1 task problem and solving it at home. Each tutorial, you may not have more than 2 questions. Okay? So we are going to do this only for 4 tutorials. Tutorial 1, 2, 3 and 5. As part of your assignment 1, self and peer evaluation. Okay, 5% marks. 15% comes from the test. Okay? So in this tutorial, there are only 2 questions like this. 2A, then I think, 1C. 1C and 2A, only 2 questions. Okay? So, but I will still give you directions. I'll explain. Okay? So I'm going to explain the problem and give you directions so that you can follow the directions to solve this problem. So what this problem says is, A clenesta, B clenesta, C clenesta. Okay? If you observe carefully, there are no commas separating the A, B or C. Okay? So A 0 or infinite times, followed by B 0 or infinite times, followed by C 0 or infinite times. If all the 3 clenestas, A clenesta, B clenesta, C clenesta, takes a value 0, because clenesta can take a value 0, maximum infinity. Minimum value is 0, maximum value is infinity. Okay? So if all the 3 clenesta takes a value 0, then the string will be an empty string. Because A clenesta 0 time means empty string 0, 0 times A. B clenesta also takes a value 0, B 0 times. C clenesta also takes a value 0, it means C also repeats 0 times. So the entire string will become an empty string. So we can have lambda. Okay? So when this clenesta is 1, this clenesta can be a 0, this clenesta can be a 0 as well. Okay? So when one clenesta takes a value 0, not necessarily the other 2 clenestas should take a value 0. They can take any values they want. Okay? Meaning, each of these clenesta can take independently values. Okay? So I'm taking another scenario. So if this clenesta takes a value 1, and this clenesta takes a value 0, and this clenesta also takes a value 0, you will get A alone. Okay? If this clenesta takes a value 0, this Tenestar takes a value 1 and this Tenestar takes a value 0, you will get B. Similarly, you can get C, you can get AB, you can get AC, you can get BC. Okay? Can I get CB? Cannot. Because C appears after the B. If you see here, the B appears after the A and the C appears after the B. That sequence have to be preserved. And that's why I've taken AC as a valid string and BC as a valid string. I did not take CB or CA. CB or CA or BA is not allowed. You can't change the sequence. So why we can't change the sequence? There is no comma separating the A, B or C. Okay? So A should appear first, followed by B, followed by C. That sequence has to be preserved. So all these are valid strings. Okay? So I've given here invalid strings are CB, CA, CAB, CBA. Okay? So if you are not following the ABC order means sequence, then they are invalid strings. If we are not following the sequence of ABC, then they are invalid strings. So I have given a few invalid strings for you to visualize. Okay? So how we should approach this problem? Okay? So you should look at the example string. So the first, I will just show you 1 or 2 steps, like fill in the blanks, then you can do it at home. So the first thing is, first is, I should be able to produce empty string. So I should be able to produce empty string. So I write my first rule as S is lambda. You see, even if you write this, you're not going to get 0, you know. You will be getting at least 1 mark or 0.5 marks. Okay? So S is lambda. Okay? So that with this rule, I can produce this string. At the same time, I should be able to produce A. When I should be able to produce A, you should apply the look ahead thinking mechanism. In computer science, this is very important. Looking ahead or thinking ahead. Okay? So I can have 1 A, 2 A's, you see. I can have many A's. So to me, it is 1 or more A's. Correct, right? So 1 or more A's. Maybe I write it here. I scribble here. So I can have 1 A, 2 A, 3 A, etc. Many A's. So my first rule is S is lambda. Then I should be able to see how to produce many A's. Right? So I can write something like this, A, and then in the next rule, I need to see how I can produce many A's. So I can say A is A, or A. So this kind of definition, we call this as recursive definition. So using this rule, I can produce any number of A's I want. Okay? But you should be careful. After A, I can have purely B's also, right? Is that right? I have 1B. And then, is this hiding? You see, I have 1B here. Then I have many B's here. So similar pattern B can follow. Similar pattern C can follow. Okay? So, I can write something like this. It cannot be right. I'm just giving you directions. I'm not giving you the entire answer. I'm tying up this A with B. Okay? So later what I can do is I can produce 1 or more B's. Okay? So what you should do is, don't forget it has to be a regular expression. We cannot have more than 2 letters. Okay? So this question is different from B or C. If you observe carefully, B and C is different from A. So here I'm not thinking in terms of a context-free grammar then converting into a regular grammar, because it is completely different. The question is completely different. Okay? So there is no similarity of A with question number B or C. Okay? So you know relay, right? In a relay, they pass the baton. Right? First fellow runs, he passes the baton. Second fellow takes the baton, he gives the third fellow until the relay race is over. Okay? Same style you should follow here. Because if you look at the example string, the language is A Ganesha, B Ganesha, C Ganesha. So if you look at the example string, A is followed by B, B is followed by C. So by telling the relay example, what I'm trying to say is, if you start with A, okay, it should lead to B, and B should lead to C. A should lead to B, A should pass the baton to B, and B should pass the baton to C. Okay, so you have to link them. So again, here A and B are connected, right? Similarly, you have to link B and C. Okay, so that each root does not have more than 2 letters. At the same time, what happens is you preserve the sequence. By writing this rule, you are forcing to start with A. Okay? You are forcing to start with A. Yeah. But again, this may not be the right answer, because what happens if you want to have purely B's? This rule will not help, because you cannot eliminate A here. Right? You cannot eliminate A here. Maybe this is how we learn now. Maybe, I don't know. This is all trial and error. Try, check whether it works or not. It doesn't work, improvise, try, improvise. So purely trial and error. Okay? So I do like this, then I can replace A with lambda. So I can start with B. Something like this. S derives AB. So I can replace A with lambda. I can have B. So I can then I put the rule here. B is lambda or BB. So I can expand the B. Okay? But when I put B is BB, I should connect like this, so that I'm passing the baton to C as well. I should link up. I should link A with B, B with C. Okay? So I'm leaving this for you to think and solve it at home. Okay? So please try. As I said, I'm not teaching this the first time. Every semester I say this, students directly, but there is a bunch of students who come to the exam. Okay? Yeah. There is also a group of them tell me, I cannot solve it. Okay? You should take all the effort, try, and then come and tell me I cannot solve it, then I can give you the answer. Okay? Not give you the answer, arrive at the answer. Okay? Simply you start thinking, oh, I want to give you a cannot. As I said, I can give you the answer, but there is no nothing. Okay? So go and go back, try home, and then come back and tell me. Okay? Because anyway, this is a assignment 1 task. Okay? So I won't give you the answer until the assignment 1 is over. The other answers, we do it in class. I ask you to do it at home also. I upload after the class is over. But those questions that are part of assessment 1 task, I repeat one more time. Those questions that are mentioned here as assessment 1 task, I won't give the answer until the assessment 1 is over. Okay? The rest of the questions, immediately at the end of the day, you can see the answers uploaded to My Times. Okay? All right. So with that, tutorial 1 is over. Okay? Except for certain batches, I have not done. I have only done up to B, C, D, E. Sorry. Here, question 1, certain tutorial batches, question D is done, E, F, G is not done. Okay, E, F, G, don't worry, even though the answer is here, answer will be on My Times. I will explain next week when I see you Wednesday. Okay, so the whole class will be synced. Okay, don't worry. So those who are under me on Wednesday, those who are under Yogeshwaran, the tutor as well. Okay, I don't think so. You also would have covered the answers for 1, E, F, and G. Okay, so it will be covered next Wednesday. All right. So with this, tutorial 1 is over. So I am going to go to tutorial 2. Okay, I don't know how many of you have read this. There are a lot of materials on My Times. Please go through them. Okay, it is meant for you guys. Okay. So there is one topic here under lectures, lecture 1 background. So I don't know how many of you have read this. Doesn't matter if you have not read this, please go and read this. Okay. So if you go and read this, it's very self-explanatory, very, very self-explanatory. And there are some example grammars as well, you know, grammar as well as derivations. Okay. This will help you to understand what is a compiler. Okay. So understanding what is a compiler will help you to understand why we are discussing this topic, this subject, theory of computation. Okay. It will also make sense why we go and study language and grammar. Okay. It will also make sense why we go for parse trees. Okay. Why we go for language and grammar, why we go for parse trees. That will make sense once you read this very simple article that goes for 2 pages. Very self-explanatory. Okay. This will tell you the purpose of we learning this subject. Okay. All right. So please read at home. So this will help you to understand why we go for parse trees. Okay. So I am going to dive into parse trees, and I am going to explain the worked example given here. Okay. So what you are seeing here on the left hand side and right hand side is actually a parse tree. Okay. You would have seen a similar structure in your data structures and algorithm, right? Your binary tree, correct, right? Yeah. This is not a binary tree, because binary tree means every node has only 2 branches, correct, right? But here you can see certain nodes have 3 branches. So it's not a binary tree, but it's a tree. Okay. But we call this as a parse tree. Okay. So why we go to this parse tree means, in simple terms, in your compiler, okay, the structure of a sentence, I'm speaking in layman terms, the structure or the structure, the template of the sentence or a word is represented in the compiler in terms of a parse tree. Okay. When you compile, whether it's a C program or C++ program or Java program or any other program, when you compile, the compiler actually goes through a series of phases. So I define at least 5 phases. Okay. One of the phases, the parsing phase. Okay. So it parses the given instruction and represents it as a parse tree to verify whether the instruction that you have entered into the system follows the rules of the language or not. Okay. Yeah, that's why it is called as parsing. So it is represented as a tree structure. Okay. Yeah. So in more simpler terms, your grammar, the grammars that we wrote, the grammar that we wrote is represented in terms of a tree structure or in terms of regular expression. So you may ask why it is done so. That is how the architecture of compiler has been defined. Okay, from day 1, the compiler was discovered until today. Okay, until today we follow this. We can't change this. If we change this, for example, if I change in my computer, yeah, okay, the program, I have to write the compiler again. Okay, yeah, I have to write the compiler again, and my compiler will work only for the language rules that I apply. It may not work with your languages. Okay, so there will be issue in terms of what we call it as portability. There won't be portability. Okay, a big issue. All right. So the grammar is written in terms of regular expression or in terms of this parse tree. Okay, I would have actually given that here. That's why I said, please go and read this. This will help you to understand things better. You see, a parse tree describes the syntactic structure of the input. That's what I told in layman terms, a template. What here I discuss as pattern. What is a pattern of string? Based on that we write the rules, right? Is other way. The compiler does parsing to check whether the tokens follow the rules of the grammar or not. Token is a technical word which I call it as template or pattern. Okay. You read this. You can 5 minutes. You can read. Doesn't takes more than that. Let's jump into past tense now. So we have a grammar here. Okay, we have a grammar here, and what we are going to do is we are trying to do two derivations here. Okay, we are trying to derive the string AAA BB. Okay, AAA BB. Yeah. That is, I am taking a valid string. AAB is a valid string following the above grammar. So I am going to produce this valid string using the grammar. Okay. So I am seeing how to produce AAB. If I follow SSAS, I also can do that. I am going to show you that. I am saying SSAS. So I can produce the first A. I need 3 more A's, right? 3 more A's followed by 2B. 3 A's followed by 2B. So what I do is I grow the A's now. So this A remains. I'm going to replace this S with AS again. AS again. Right? So now I think if I produce one more A, I will be stuck because I already have 3 A's. Next, I need to have actually 2 B's after 3 A's. So no point me expanding the A again. So I roll back. I think what I can do. I can see I can apply this rule. SSAAB. So I'm going to replace S with AAB. You will come to understand why I'm applying this rule shortly. So now I can see that A can be replaced by B. A can be replaced by B. So what I'm doing is AAA remains. I can replace the A with B. The last B remains as it is. So I produce AAA BB. Okay. So this is one possible way of producing the valid string AAA BB. Okay. So now I am going to show you there is another way, or I can do another derivation to derive the same valid string. Okay. So what I am going to do is I am going to use the rule AAB now. Okay. Because I already saw here A can be replaced by AA. Meaning, I can produce A's not only applying the S rule, I can also produce more A's by applying the A rule. I saw that already. Okay, so I am applying this rule AAB. The next step A remains, and I am going to replace this A with this rule. A is AA. You see my intention, huh? So I already have 2 A's, right? So I need to have 2 B's, right? So what I can do? I can again expand A as, can I expand A as AB again? AA again? Can, right? I can expand A as AA again, right? Still lost. I'm expanding A, capital A as AA again. AA again. Thus last B remains. So what I want to have, I already have AAA, I need to have one more B. I already have a rule here, A is B. Correct, right? So there's a rule A is B. So I can keep the AAA's, I can replace the capital A with B, the last B remains as it is. So if you observe carefully, there are 2 different derivations to arrive at the same string. Okay, there are 2 different derivations to arrive at the same string, same valid string AAA BB. Okay. So, I'm going to say this in a different way. There is more than one derivation possible to derive the valid string AAA BB. So what? Okay, so what? You may ask, so what? Okay. If a grammar for a valid string can produce more than one derivation, we call that grammar as ambiguous. Because in compiler, the grammar cannot be ambiguous. So you may say, I don't understand anything. Okay, let me put in very simple terms. When a string has more than one derivation, in the compiler, it means that one word has more than one meaning. Okay? So, when the compiler want to check whether a string is valid or not, if it has more than one parse tree, I'm going to show the derivation in terms of a parse tree shortly. Okay? If the compiler sees that a string has more than one parse tree or more than one derivation, it gets confused. It doesn't know which is right. To a compiler, a string can have only one derivation possible. Other words, a string can have only one parse tree possible. Then we call that grammar as unambiguous. Okay? So when we write compilers, the grammar has to be unambiguous. It cannot be ambiguous. So ambiguous means the grammar, a valid string in a grammar has more than one derivation or more than one parse tree. Okay? We cannot have that when we construct compilers, because compiler will get confused. It won't understand when a string has more than one derivation or more than one parse tree. It cannot recognize which derivation is right, which parse tree is right. Okay? That's why we say in compiler construction or compiler design, the grammar that we write for a language has to be unambiguous. Okay? So I'm going to show you how to draw the parse tree for these two derivations. Okay? Let me bring this down so that you can see the parse tree in the same page. And I'm going to draw and show you so that you know how we draw. Okay? Or how we construct the parse tree. Okay? Because if I just explain with the answer, you may able to see it, but later when you want to draw a parse tree or construct a parse tree, you may have difficulty. Okay? So how this derivation is made? S derives AS by applying the rule S is AS, right? S derives AS is derived by applying the rule S is AS. So I am going to do that here. So I am saying S derives AS is done applying the rule S is AS. So I write A, I write S here. This is small a. Eh? So I connect them with lines. I'll repeat one more time. This derivation, S derives AS, was derived applying the rule S is AS. So that's what I'm writing here. S is AS. Can I write like this? Cannot. A lot of you might tell this what can and what cannot, right? But still people do the same mistake. Okay, I can only tell you what is right, what is wrong. If you do what is wrong in the exam or test, it's going to cost you. You're going to lose marks on me. Okay? Yeah. Why I tell this means I tell this every semester, but still there will be a bunch of students. They do what I say is wrong. How to help it? So you cannot write like this. Why you cannot write like this? The compiler does the parse tree like this. It does the parse tree like that. Okay? This fellow doesn't have brains in it. Okay? You have to understand that. Even though we say it is intelligent, and today we are talking a lot about AI, don't forget that AI that we do is created by these brains. The brains of you guys. Okay? It is not directly from heaven or sky. Okay? You have to understand that. Oh, this has AI, it can automatically find mistakes. How that AI can automatically find mistakes? It has been programmed to do so. And that programming is done by human brains. Okay? Not some aliens. Okay? Yeah. So, you have to understand, this is science, it's not black magic. Okay? So why is this wrong? This is not how the machine does it. The machine does that. Okay? So you can't write like that because S is AS, the rule is represent the parse tree like this. Okay? Or the next step. So now, if you observe carefully, this A remains as it is here. This A remains as it is here. This S has been replaced as AS by applying the same rule S is AS. Okay? So I'm going to do that here. So S is AS again. A S. S is AS again. Now, if you observe carefully, these two A's are here as it is. So what we have done, we have replaced this S with AAB. Okay, this S with AAB, applying this rule, S is AAB. Sorry, applying this rule, S is AAB. So I am going to do that here. S is A, capital A, B. Tablet means will be easier. We can scribble with a pencil. Now I can do it on the board, but I'm afraid those who are at the end of the hall, they will see it is very small. Yeah, that's why you have plenty of seat in the front. You should come and sit in the front. I don't know, like in a cinema theater, you watch it at the back, right? My mind is. It is you that you are paying 100,000 plus for 3 years. So you decide what you want. It's your preference. Okay, let us not go there. Okay, so if you observe carefully, these three A's are already here. This B is this B is also here. Okay, so what we have done is we have replaced this A with this B by applying the rule A is B, right? So I am going to represent that here. So A has been replaced by B. So I am done. I am done. So how to read this? How to read this parse tree? You do depth first search. Okay, depth first search your data structures. So from the root, you go to the left subtree, A. You read only the leaves. Okay, you read only the leaves. So A, that's a leaf. So backtrack, go to S, go to the right subtree, go to the left subtree, A, backtrack, right subtree, A, backtrack, A, go to the leaf B, backtrack, go to the right subtree B. So if you read only the leaves, it is A, B, B. Triple A, B, B. Okay? Same thing is done here. If you observe carefully, I am saying S is AAB. It is here. The derivation S derives AAB is done by applying the rule S is AAB. And that's what I have done here. AAB. In the next step of the derivation here, this A remains as it is. This B also remains here as it is. So what we have done is we have replaced this A with AA here by applying the rule A is AA. So that's what you're seeing here. A has been replaced by AA. Okay. The next step, what happens? This 2A remains as it is here, and this B also remains as it is here, and we have replaced this A with AA here. And that's what we are doing here. This A here is replaced with the AA. The last step, we have replaced this A with this B, and that's what you're seeing here. A is replaced by B. So if you look at the two parse trees, they are different. They are not identical. Identical means exactly the same. Okay? So here S has 2 branches. Here S has 3 branches. That itself is good enough to say that this parse tree is different from this parse tree. Okay? So I roll back. A grammar is said to be ambiguous if a valid string in the grammar has more than one derivation or more than one parse tree, then the grammar is said to be ambiguous. When we write compilers, the grammar should not be ambiguous. So how to find out whether a grammar is ambiguous or not? Using derivation or parse tree. No need to do both. Okay? No need to do both. Okay? You are required to do either derivation or parse tree, whichever you feel comfortable. But normally I will advise you to follow derivations because you won't go wrong, easier and faster to do. Okay? Because parse tree means you have to draw. Okay? Derivation means you just write. It's faster and easier. You won't make mistakes. In parse trees you can make mistakes. I won't say you will make mistakes. You can make mistakes. Okay? You could make mistakes. So better to follow derivations. Okay? So here I have explained what I did just now. Because this is an example problem, worked problem. Example worked problem. Okay? So I've explained the example worked problem. So what I'm going to do is, actually what you see here, what I explained here is given as answer here. I've actually explained and I've given the answer. Okay? I've explained and given the answer here. Okay? So now this is done. Okay, question 1 is here. I was searching for the question. So before we go into question 1 and question 2, question 2 and 3 is actually take-home exercise, assignment 1 task. Before we go into question 1, let me take the attendance because 6:53 already. Attendance will expire. Then I will explain question 1. You are in the leaving. Okay. Anyway, it's going to be 7 o'clock. I think already you are in the leaving mood. Just give me 1 minute. So what I have discussed in class is just the worked example. So in the tutorial class, I will discuss question 1. I'll give you direction for question 2 and 3. And we will discuss question number 4 as well in the tutorial classes. Okay? Thanks for joining me today. Have a good day. Bye-bye.